Good afternoon, everyone. Hope you've had a spot of lunch and you're refreshed. We have another 3 speakers this afternoon, and then we'll have a break for a coffee before the final 3. So our next speaker is Heidi Vaniparis. She comes from the Danish Agency for Data Supply and Infrastructure, and models is Heidi's thing. And I do like the title of the presentation, models in action, as if they're going to be doing an assault course or something like that. So over to Heidi. Thank you, Heidi.
Yes, thank you. So as already mentioned, I come from the Danish Agency for Data Supply and Infrastructure. That's a long name, but informally, you can also say that we are the mapping agency of Denmark. We work with data, we provide data to other organizations, to other agencies in the government, to citizens, to companies, especially geospatial data, but it's not limited to that. I work in a department where we are kind of in the core of the agency, as we say. So we interact with a lot of other departments, and it's all about data. So we maintain the data, we have the databases, we take them in, we distribute them further. I work, amongst others, with data modeling together with some colleagues, and I'll talk about how we use UML models in our daily work, and how that gives quite some benefits for us. So basically, in short, I would like to explain afterwards in a bit more detail how UML modeling helps us in the different phases of the life cycle of datasets. So from creation to storage to users and to archival in the end. And that's a bit of a simplified life cycle. Of course, you could add more stages, but for the purpose of this presentation, it's good enough to present it like that. I didn't really know the audience, so I can see there's a lot of people here, at least in the room, that know all about UML modeling. Perhaps there's some people online that know a little bit less, so I thought I will just have a very short example of what is UML for those that have no experience at all. So I created a small model, and a very attentive and experienced user will notice there's already a few mistakes in there, so I'll correct that afterwards and create a new presentation. So, but basically, what is UML and what can you use it for in terms of data models? So it's basically a formalized way of describing what there is, what you have of data. So what is it you want to maintain, store, distribute data about? There's different entities. We call them classes in UML. So if I take the example here of we have this meeting today, actually all week. So that's one entity, that's one class. We have an organization, perhaps more organizations that are organizing, that are hosting the meeting. And in the meeting, there are different persons. You are attendees, at least for the moment. I'm also a person, but I'm into the meeting in another role. I speak at the meeting, so that makes me a speaker. And then about all those entities, you can maintain some extra properties if you need to have some registration list, and perhaps it's good to have like a first name, a last name, etc., etc. So it's basically a formalized way to model those statements about meetings, organizations, and persons, or anything else. Typically, of course, in our case, geodata. It's you can do UML, but just using diagrams. But if you want to use it in a SmartMay, then you would not only have the diagrams, then you would actually create a model. So you would have a tool that has a model, and the diagrams are just a view on that. And in the model, you can also record extra information. So UML is extendable in different ways. So one way to extend it is that you say, okay, I would actually like to add some fields, some properties for storing information about all my different model elements, about my classes, about my properties. So something that we do in Denmark is that we have, we use these more like terminological principles that, okay, Documentation is a good thing if you divide it a bit in, okay, what are the labels? What is the short, concise definition? What are the notes? What are some examples? So we define fields to store that information. So all that documentation is an inherent part of the model. So that was the very, very short and concise introduction to UML, just to give those of you that don't have experience with it an idea. So when we come to the first phase, that's the creation phase. So if I look at what we do in my agency, there's, broadly speaking, two different ways of getting data into our organization. The first one is that, yeah, we call it, and we have our eternal master data. So some colleagues would actually enter data in the systems. Actually, you can of course use UML for doing that, but actually me and my colleagues are not so much involved in creating UML models for those, yeah, production systems. Although of course you could do it, and we have done it in a few cases. Typically where we use data modeling a lot is where we take into our organization a copy of what we call external master data. So it's actually another organization that is responsible for that data set or for that register. But because it could be many reasons, we actually would like to have a copy of that, so we can use that in our analysis, in our flows, to combine it and create, yeah, extra knowledge or develop some solutions that benefit from having this data. So typically we would go in there, and in that phase, the purpose of the UML is really to like reach a common understanding between humans. So we perhaps may have some idea, and then the people who want to deliver the data to us, they have some idea. So we use this UML modeling to reach agreements. Okay, you say that, is that what you mean? Then we draw it, and then we communicate, explain a bit about UML at the same time. But that is really what we use it for at that point. So what we can create at that moment is that the model is one thing, but you can create different views on it. So you can like export it in different ways, present the information that is in the model in different ways. So one way to present a model is what we call in the technical community here is a feature catalog. Could be a Word document or an HTML document, and it's basically like a specific way of showing the model. So it's like a combination of the diagrams, and then you go through each object type and each property you have, and you put the description in there. So that's something you can, yeah, easily send by mail to persons and say, okay, this is what we think we agree on. Please review and give me your comments back, and then we can discuss again. Something we also often do is, because we notice that a lot of people, they like tabular structures, they like tables. That's the way they are used to seeing information, so they would like to see something like that. So we have some scripts that can actually take the model and extract, for instance, the definitions and the notes, and we can present it in tabular formats. And for one model, I actually got really positive feedback, because people were having issues with like UML and multiplicity and what's that. So I created like a script that kind of translated that. So instead of saying a multiplicity and then some constraints, they basically said, okay, is this mandatory or optional or conditional? And if it's conditional, what is the condition? So again, it's the same information, but it's presented in a different way, in a way that some people are just more familiar with. So it helps again and helping them understanding what it is. And actually, with this data dictionary, it's really just like CSV files that we then put together in a spreadsheet. So if we make a model for others, then we would usually give that spreadsheet to them and say, okay, you know what, it's your data. We don't know what this means. You have to provide us the definitions. So instead of us having to type in the model, or instead of us having to explain how they update the model with the program enterprise architect we use, they get the spreadsheets, fill it out, and then we can import it again. And that way we can record the information in the model. So if you go to the next phase, the storage phase, we have in our agency, we call it our common database. It's some kind of data warehouse. So we have quite some production systems, but we have some architectural principles that all the data that we want to distribute further in the system, they have to be present in this data warehouse. And we have like rules saying, okay, if you want your data in here, it must be documented using this UML data model with all the documentation on it, etc., etc. And it's like a conceptual thing, this data warehouse. So it contains both vector data, also other data. But when it comes to the vector part, it is really just an Oracle database. So that part is relational database. So what we do in that phase is that, we call it, we push the button, very simplified, but we say we push the button, we use shape change, and we create a DDL file. So basically a set of create table statements and indexes, etc., that are based on the model. Of course, you go from like an object-oriented structure to a relational database. So you need to do some, we call it flattening. So there's this flattening transformer, if you know shape change, that kind of takes those structures and adapts them so they are actually fit for having in a relational database. But like that, like as one of my colleagues said, if there's a typo in the model, there has to be a typo in the database, and that's the case. So if you have a typo in one of your attributes, you will see that the column is called the same, perhaps a bit shorter. Oracle needs to be a bit shorter sometimes for the column names, but that will be there. And the definitions that are present in the model are also in that DDL. So we have the comments on the tables and on the columns, and there they contain this definition. So if a database administrator or just a database user goes in, they can actually see what is this column, what does it mean? They can see that from there. So then we have the next phase, the usage. And I think this is perhaps the most known or the most traditional way in which a lot of organizations that use UML modeling use shape change, because often you would use this to go from a model to a GML application schema, and then that GML application schema can be given to the people that develop the services that then provides GML, so the web feature services. Recently, we've also been using it to create GeoPackage templates. Like traditionally, we provide, shape fields, shape files, and map info and SAP, and there's a whole lot of files that people really would like us to support. But we would like to reuse the number of formats, both because proprietary formats is that something we want to support as a government organization, and it also takes a lot of resources to support all those different formats. And people always have new ideas of, can we also have CAT files, because we have some colleagues working with that. So we try to reduce that. So we create a GeoPackage template. So if you don't know, it's like it's based on SQLite, so a portable database. So those inputs we give to the people then setting up the services or the download services where you can directly download. For instance, for GeoPackage, then we use FME. People that develop, they get the templates, and then they just have to put the data into it, and then again be further processed and be made available for the users. So especially when it comes to GeoPackage, then having the definitions and the other documentation at the model is really an advantage, because if you use GeoPackage in a certain way with a document, I think it's called a schema extension, then all these definitions actually are in the GeoPackage file that the user gets. So it really is a self-documenting file that the users get. They can always still consult the feature catalog, etc. But the information is actually present in the file itself. Definitions are also present in the GML application schema, but again, it's split because you have the GML and the GML application schema. So I'm not sure how many people actually go in and read that when they connect to a web feature service in for instance, QGIS or another case application. So, and then the last phase is the archival phase, and that's really something that is very new for us in the organization. It's really like work in progress. So the reason why we started looking at that is basically, save money. So there's some rules in Denmark saying we have to use less consultants. So we have to see, okay, where is it that we can take that work back in again. And yeah, we are a government organization, and there is legislation saying that whenever you make an IT system, you have to tell the Danish National Archives, and then they will assess whether that is something that is valuable for the future. And if they say yes, then when the system is no longer being used, then you have to, like, create this, they call it a submission information package with all the data from that system. And it has to follow their requirement specification, of course. So a colleague of mine has been looking into that. And the Danish National Archives, they give some tools that you can use. So one of them it's called a database preservation toolkit. And what it does, if you have a database, yes, then it will read the information, so the data, but also the schemas, and then it creates that submission information package, not complete, but it has a lot of the information already. So just to show an example, so on the left side, again, there's the create table statement that we have. So we have the comments in there. So what the tool will do is actually take all the information about the tables and the columns and also their description and put that already in one of the XML files that is part of that information package. So here we really see the advantage of having made the efforts of documenting, having made the efforts of having that documentation in our database, because now with, again, simplified one push on the button, then we have done a large part of creating that submission information package instead of having to talk to a lot of people, finding out where's the documentation, entering manually one by one. So the database preservation toolkit, it's used for converting the non-geographical data into that submission information package. What we then still need to add is the geodata. That's special according to the National Archives. For some reason, their specifications said we have to deliver geodata in 3.1, but luckily, shape change to the rescue, it is actually possible. So again, we take our same model, use some profiling because we only need the identifiers and the geometry, not the rest because that was already present in the package. Then we create a GML application schema, and then we can, by means of FME, take those geodata and the identifiers and create the GML files and place them into that submission information package. So again, work in progress, but we have good hopes that we will actually succeed in delivering our first created package in-house. So that's basically, in a very short way, how we use UML models in the agency. Perhaps just a disclaimer, it's really simplified, right? So we use that expression, push the button, a lot because it helps explain our colleagues that if you do the UML data models, that gives you a lot of advantages because a lot of it is automated. But it is a lot of iterative work. You need not only push the button, but you actually need to create a configuration file beforehand. So you need to know a bit of XML, you need to know the options. It's good if you know the internals of ShapeChain sometimes to actually make it to what you want. We're really pushing it to the limits. But for us, it still gives so much advantage that, yeah, we would definitely keep on doing that and recommend others to do so. And that concludes my presentation.
Thank you. Thank you very much, Heidi. I'm sure there's some UML model experts in the room. Has anybody got any questions for Heidi? No? Okay, I've got one. You've got, what really struck me about it was that you've got UM models and what you talked about the different stages. So once that data reaches the archive, then you'll end up with a very good record of what's happened to it from capture all the way through the process. And I can envisage in the future, if we are supplying complex data sets to particular customers, they might want to know what that lineage of data was, So do you think the system that you've put in place now, you'd be able to look up a data set in 18 months' time and work out how it's worked its way through your system?
You mean like with the information package?
Yeah.
That we create? Well, that's actually for us, it kind of stops there, because then we deliver it to the Danish National Archives, and that's it. Often it's because we change the system, so we would still have the data. It's just that now we created, for several reasons, a new system. So the data kind of lives for a very long time, right? Yeah.
Okay. Right. But you'd be able to trace through the model through its development to see.
Yes.
To see its path through your organization.
Yeah, that's true. Yeah, and what I didn't say is that we also version control the models.
Yeah.
So we know what changes we did and do some versioning, and all the documentation I showed, we store that on a place so we can actually see.
So it's quite a powerful tool for going backwards, looking back. Yeah.
Yes. Yeah, we can see that how the model changed as well, not only the data. Yeah.
Okay, thank you very much.
We have a question from Trond.
Yeah.
A short one. How many are fluent in UML, would you say, and how many needs to be fluent to have an efficient kind of working environment?
We are around 5 persons that actually do this. So you need to be a few, otherwise, because you can't deliver to the rest of the organization if you're only 1 or 2. So you actually really need a team to be able to do this. Yeah, that's true. And then you also need at least, I would say at least 2, but rather more, that also know how to do the scripting and that know a bit more of shape change. Yeah, so the scripts I showed, like with creating the data dictionary, that's something we created ourselves. So you need people that can also do that, so that if I get sick, then actually somebody can take over. So you need some kind of, a minimal group to make it sustainable. Otherwise you depend on one person, and that's very risky. Yeah.
Okay. Thank you very much, Heidi. Okay, our next speaker is Trond, and Trond's going to talk about the collaboration between GIS and ITS. I'm guessing ITS is Intelligent Transport Systems, and the challenges that we've seen with joint working Group 11. So thank you very much, Trond.
Thank you. Thank you for the kind introduction. And in this, I'm Trond Hovland from ITS Norway. So ITS, I don't know if everybody is familiar with the ITS concept. That stands for Intelligent Transportation System. It is in the middle between transportation sector and the ICT sector. So everywhere when those two sectors meet, we have a mandate to work. That means you can work with ABS brakes on cars, on ticketing systems, traffic management system, traffic lights, harbor systems, fleet management system, and stuff like that. So that's our world, and GIS is a very important component in that world, and that is this kind of short presentation is all about. I will do it together with Jonathan Harold Booth, who is on Zoom. He will take over in a while, and I will just start a little bit before he gets the floor, so he can present himself afterwards. So I want to divide this into 3. Why do we like to do this? We are in ITS associations like ITS Norway. There are 27 ITS organizations in Europe. There are like a little bit less than 100 in the world, and we are motivated by the fact that we need the geographical component to be much stronger than it is today in the ITS world. And then I will tell you a little bit about the gap and why we are doing it, and hopefully sum up within the time. So this is the backdrop of our world. We look at all the transportation modes: air, sea, rail, and road. Road is definitely the most mature in our world. This is also far advanced when it comes to the use of ITS in the way that we portray it in any way. But what we are busy about is to integrate all the modes of transport and the harbor, ports, station, terminal section in between them. And we do that integration to be able to optimize the use of each vehicle, each vessel, to have seamless transportation through those modes and the stop places and terminals and stuff like that. And we do that for both the goods and person transport. So long before you kind of feel that you have a kind of an enhanced traveling service, we can still integrate in a way that you use each vehicle, each vessels a little bit more efficiently than before. So it's constant making progress in that area, even if you don't kind of notice as a user at the moment, but the environment will notice sooner. So this is the big backdrop. But coming from the transportation sector, most of us in the ITS sector comes from road administration and road maintenance and operation phases in our lives. So this is a picture for a normal kind of database legacy from a road owner system. You know the manholes, you know the curbs, you know the lane markings. You have that in the database somewhere, and you also have the traffic rules and regulation in that base. Even in some kind of databases, you also have the number of trees lining the streets, and you have the curbs and what type of curbs are available. So you have all this information, but that is not enough for the future, because when we are moving into a future where you have more automated vehicles, more autonomous vehicles, like you see in the picture down to the right here, that is a Waymo car from downtown Phoenix in Arizona, which is driving around kind of in that green field in that map that you see in the picture. That map is highly defined by a map in centimeters and millimeters. They know exactly how high the curb is. They don't care that much about what type of curb, but the height of it and where you can cross over it. And also then you need to know if they cross over a bike path at the same time. So they need a lot of information that is really accurate. So coming out of the old-fashioned road data kind of maintenance operation style of working into that new area where ITS is dominant, that is where we are going to work. In the left side of the picture, you have the legacy GIS prevalent, and in the new one, you have ITS data and also maps. So this is another way of portraying it. Down to the right, we have the legacy kind of GIS TC211 maps, which we are used to kind of work with. But we have to take into consideration that the cars on the roads also make up their own maps as they drive, and they share information, at least with TomTom and here. So you have kind of an alternative reality that compares and competes with the map. And you also have on the left side, you have the navigational maps that are slightly different from that again. And then in the future, you will also have sources like point clouds that are really accurate, but lack content maybe for each of the objects in that picture. And then again, you have the building information models that also provide a lot of important details for the road. And sometimes we miss using that because we have no kind of way to flow that data into the maps in the GIS world, into the ITS world. So this is the kind of the system where we are trying to work on at the moment. So this is Knut Jetlunds. I think most of you know him. His thesis, he has been looking at the relationship between BIM, GIS, and ITS. And also at the moment we have a working group, joint working group between BIM and GIS. And we also have the one that I'm heading up in between GIS and ITS, which is which kind of present two different kind of map worlds. So there is a gap between those two gap worlds, and that is what I am going to go into a little bit now. This is the definition or the scope of TC211. It is too small for me to read on the screen here, but that's like the static world of the maps where things are put in context and is at rest, at least almost at rest. I know that everything moves anyway, but when it comes to TC204 and the scope of that is everything that is using that map on the left side, but then are in movement, like traffic regulation, traffic management, fleet operations, and everything that has to do with travel and movement. So those two are quite different in style and format and in intention, but still they should be able to communicate easily between them, and that is not the case. Even though when I started working with Olaf back in 1999 or something like that, they work quite similar. At the moment, they are not. This is the package of work. This is the working groups of TC204, which in red is denoted geographic data files, which is the kind of map database that is used for all the other working groups and all the standards that are provided in each of them. This should have been kind of aligned with the TC211 concepts and principles and standards to be able to kind of communicate between the legacy mapping authorities, road administrations, and with the cars on the roads in real time. This used to be kind of almost similar in the end of the 1990s, but they grew apart. GIS specialized for ITS purposes, and GDF specialized for ITS purposes, and DIS was an all-round kind of system for all kinds of maps and all kinds of domains. That gap is constantly increasing at the moment. We lost a lot of interoperability due to that. So what we're doing in the real world at the moment is that we're putting up entities like the one you see in the middle here, TSA, TPEG, DATEX, the TNITS, TomTom here, to help bridge that gap in very expensive way, because you take data from the left-hand side of the screen and you put it all the way over to the cars on the roads that communicate with each other with kind of roadside equipment and then share data. But you have to do a transformation and that's why you have these that's why you have these entities in the middle like TPEG, TSA, and so forth. I think even if you harmonize the two worlds, those would not go away immediately, but they will be far cheaper to run. So the things that we are doing is to try to take the current GDF version, that is 5.1, and kind of translate into GDF 6.0, but base it completely on TC211 principles and concepts for the future. So we put up, we set up a joint working group 11 with 3 work items. One is to kind of identify the gaps, and then to see how linear and location referencing work together, and finally look at the terminology that is also a kind of a gap in. So we needed to do all of these 3 things, and we set up then another work item, TR19169, and this is where I hand over to Jonathan Harrow-Booth. So if you can hear me, John, I'm happy to. Good.
Indeed.
I'll be silent for a little while.
Okay, I'll do a very brief self-introduction. So I'm John Harrow-Booth from the UK. I'm currently talking to you from a European Commission office in Brussels, and I'm an ITS specialist who has a lot of interest in maps and spatial data. So I'm going to turn my camera off just to save a little bit of bandwidth. So as Trond was saying, in this collaboration between the GIS and the ITS standardization worlds, this was the first product and is a technical report that basically looks at GDF, which is an ITS product, and says, how should that change? How could that change to make it more like a GIS and more aligned with GIS standards, still to perform its function, but really improve that alignment. And I'm not going to go through the details, but it covers a raft of different proposed changes, restructuring the model and how model elements. So going back to Heidi's talk, some of the detail of the UML modeling, how that works, how that and how the UML model is transposed into languages such as XML. All of that are part of that consideration. Plus, aligning terminology. We've developed our own way of understanding concepts in the GIS and the ITS worlds, which actually point at the same concepts, but use different terms, and trying to align that terminology as well. Next slide, please. So that piece of work was done and provides a very strong set of recommendations. It doesn't provide a plan. And I say that with a smile on my face, in that you can produce a set of recommendations that everybody sagely says, yes, okay, that's all very sensible. We are taking what is effectively a monolithic standard. GDF is let me say 2,000 pages long. It's a very dense standard. And one of the recommendations, the first recommendation, is to modularize it, to split it into different pieces that can have their own life cycle. Some things will update much more frequently than others, and that makes a lot of sense. But actually, you're then going from one standards work item to multiple standards work items, and that causes you some practical problems about management, resources, timing, scheduling, and how to make that work. And so we've established a preliminary work item to look at that question of planning. And ultimately, that comes down to what is the sequence of new work items that would come forward to produce this new version of GDF. Next slide, please.
John,
Yes, hello.
we've got about 5 minutes left.
Okay, that's fine. So one of the very interesting discussions that arose in that joint ITS-GIS meeting was really trying to ensure that this new version of GDF, which is an ITS product, really meets the user needs. And so we've been undertaking a range of stakeholder engagements, and it's a fairly straightforward, although nuanced question, which is, do you see a need for a global road data model standard? And actually, almost universally, the answer is yes. And people would say, well, isn't GDF, the existing GDF, that? It is, but it needs to evolve. Our requirements are evolving. Automated vehicles are coming. The demands on navigation are increasing. Plus, other worlds like BIM are also placing further demands. And so that needs the thinking needs to move on. Next slide, please. I certainly didn't produce this diagram, and I'm not expecting to spend any time on the detail, but industry bodies have produced this, which is one view of a world, of an ecosystem of spatial data standards in the ITS world, and how data goes from the source and is fed to vehicles, and how vehicles can act as a sensor and provide map and spatial data back, and how the various technical standards might fit together. And what's interesting is I would point to the cloud bubble on the left-hand side, proprietary services, and say that's actually an area where there's a lack of existing standards. You'll see ISO TC204 and ISO TC211 are listed in there because that's really the space that this new GDF should be operating in. But we have to recognize that that is a standard within an ecosystem of a set of other specifications and standards, some of which are formal, some of which are industry. Next slide, please. So what we are seeking to do is really to align with the ITS and GIS concepts, but also create something which is clearly useful and usable for a very broad spectrum of user base, but includes some challenging areas. What are the spatial data needs for an automated vehicle? Answers on a postcard, I think, is the English phrase, because it's an area where there's a lot of discussion going on, but not many answers at the moment. And therefore, as standardizers, we would say we really want to gather and use that research information. Next slide, please. And why do this? Why produce a new standard when there's a lot of industry activity in this area? Ultimately, certainly from a European context, road authorities are going to really struggle to use an industry standard that doesn't have any formal status. It really can't ever be referenced in regulation and legislation, and there's always a theoretical risk that commercial entities could impose commercial restrictions. So the need for a formal standard in this space is very strong, but it requires a lot of effort and work. And we need to try and make sure that it aligns with the broader set of user needs. Next slide, please. So we are looking to initiate those work items to revise GDF as that baseline standard. We clearly need to gather and are gathering stakeholder inputs. We probably need to be more proactive and more visible in that space, but the work is ongoing. And at this point, I'll hand back to Trond.
Thank you so much, John, for that explanation. And on my watch here, it's like still 3 minutes, but I'll be quick. Yeah, okay. So I'm going to sum up, okay? Yeah. So if you just remember back when we started, ITS aims to kind of support multimodal operations. And that means we need one standard map for all modes to actually be able to operate. The road sector is the most advanced, so we should start there and at least map align that one. So doing that, we have this kind of scheme where we are working our way through. From the left-hand side, we take into account the TC211 GIS. At the same time, we do, as John said, we are working with the TomTom here to make sure that we have the requirements from other map makers, from TNITS, CCAM, OADF, and stuff like that. We also need the requirements for them. Finally, we will end up with a GDF 6.0 that kind of harbors a global road data model that is slim, robust, and is easy to make extension from. And that is a road data model that will kind of help use not only ITS systems, but also align with the legacy kind of data system at the road administration around the world, cover Inspire, and also make a pipeline for HD maps. So standardize a global road data model as GDF6 is what we are setting out to do. And that concludes my presentation. Thank you.
Thank you very much, Trond. I think the one thing that gives me great encouragement by this talk from Trond and from John, it is the realization that this fragmented transport piece does need to be consolidated in some sort of way. So the one question that I have for you, Trond, is that because it is a sprawl at the moment, there is a lot going on. There's commercial actors, is what's been said. Do you think we've missed the boat in this, or do you still think we've got an opportunity by following down this GDF path?
I think we'll miss the boat if we are not doing it now.
Right.
I think now is the time.
The next couple of years.
Yeah. In 2025, if we start then, it will be too late.
Right.
So I think even though I think we used a lot of time to get to this point.
Yeah.
Most of the work was done by John and the other guys in the committee. And I think we couldn't have worked faster, even though it was a slow progress to here. But now we know where we are going. Okay. We are on time.
And your joint working group 11, has it got some impetus to get going then, has it?
Sorry?
Your joint working group 11, has it got impetus to make a start and get going?
Yeah, we will make the head start of that, yeah.
Right, okay. And we got a quick question for Trond on transport. Oh, really interesting. Thank you very much, Trond. Thank you. Okay. The last talk before lunch, before our coffee, is from Serena Cortez from South Africa. Unfortunately, she's unable to be with us, but she's a star because she sent a recording, and Friedrich here informs me that it is exactly 20 minutes long in a couple of seconds. So we'll listen to Serena and please, I think our details are on screen. So if you want to pick her up on any items that that come up, then please contact her directly. Thank you, Serena.
Hi, everybody. I'm so sorry that I can't be in Stockholm today, and then due to unforeseen circumstances, I can also not dial in today. But as most of you know, I'm very passionate about addressing standards, and so today I want to share with you something about the standard we are currently working on. It's about assigning and maintaining addresses for objects in the physical world, ISO 19160-2, and I want to look at why conformance matters and how one can show conformance to this standard. As you all know, when we grew up, addresses were mostly used for physical delivery. They were something that was used in the physical world. Today, that's very different because we now use addresses for navigation on our mobile phones. We use it for utility planning and maintenance. We use it for automated mail processing. And very often the address becomes like the common reference for different sources of information. And then it's important that there is an address, that it's correctly assigned, so that we also can do analytics with all these different sources of information. This renewed interest in addressing and address data in our new digital world calls for the interoperability of addressing and address data. And so for this reason, in 2008, we had a workshop not far from Stockholm, where you are today, in Denmark, and we discussed if and how standards for addresses and address data should be developed. A particular challenge of addressing and address data is that there are these different dimensions and we always have to keep them in sync. First of all, there's the address in the physical world. It's very often a street name or a number or whatever. And we also need a digital representation of that in the data, and it needs to stay in sync. And then there's also the people, the human dimension. And they sometimes have a perception of what the address should be based on many years of using a particular address or just based on their cultural identity. And anybody who's lived in an area where addresses change will know how important it is to also consider the human view on addressing. Following the workshop in Denmark in 2008, we started what we call preliminary work on addressing in ISO TC 211, considering all the different aspects of addresses and also how they could be standardized. So what you see here on the left-hand side is just to see what is an address and what are the address components. Under rendering, you see the different challenges of showing addresses on mail or other delivery items, for example, showing them on maps. And then at the bottom left, you can also see how we then would represent this digitally. So that's about the address data. But it's also about addresses in the physical world, as you see in the bottom right. And it's the bottom right that ISO 19160-2 addresses. When we concluded the preliminary work on addressing standards, it was recommended that 5 parts are developed and the 6th part emerged later. So the first part would look at what is an address, what are the components, how do you combine them, how do you describe that. The second part would look at how addresses are assigned and maintained in the physical world. The third part would look at data quality. The fourth part was about how you render addresses on mail and delivery items, and that proposal was to develop that together with the Universal Postal Union. Then there was a proposal to do one on how to render addresses on maps. And the 6th one is more about the services that you would need to exchange addresses in the digital world. This project on the preliminary work brought together all the necessary stakeholders involved in addressing. But we realized that some of these recommendations don't strictly fall within the scope of ISO TC 211, particularly the second part, which looks at the assignment and maintenance of addressing. So we consulted widely with other TC 211 committees, with other standard bodies, but it was eventually decided that TC 211 can go ahead and develop this because nobody else was really interested, and it would make sure, or it would make sense to have a single suite of addressing standards developed by a single standards body. The current status of these standards is that the first part, the conceptual model, which describes what an address is and how one describes the addresses in one's city, country, region, was published in 2015. The second part, which I'll tell you more about today, is currently under development and publication is expected for next year. The third part was published in 2020. And then the one on addresses on mail items was published in 2017, and there's currently a revision ongoing through the Universal Postal Union or in collaboration with them, because this standard is published both by the UPU and also by ISO TC 211. Then we had a report about rendering of addresses on, for example, maps, things other than mail items. There was a report in 2018, but it was decided that there's not really a standard needed to look at this. And then the digital interchange of addresses was cancelled, and hopefully in future this can be revived again, because I think this is really important if we think about the future of where addresses will be exchanged. This standard is definitely needed. Before we move on to part 2, I just want to give you a brief overview of part 1 of the addressing standard. This describes what an address is. It's essentially the UML model that you see there, which says that an address consists of different address components. For example, a street name, a street number, and a place name. and that an address is typically assigned to an addressable object. Either the address can have a coordinate, a location, or the location of the address is kind of inferred from the addressable object. Several countries or communities have developed profiles of this first part of the addressing standard. They explain then in this profile what their addresses look like in terms of that UML model that you saw on the previous slide. Here is an example of the British addressing standard, BS 7666, and it describes in terms of ISO 19160-1 what the addresses in Britain look like. And these descriptions of different kinds of addresses then make it possible to integrate data from different sources into a single database. What you see here are some examples from my country, South Africa, from Statistics South Africa. City of Tshwane is a municipality, and Dr. Ruth Mompati is another district municipality. So you can see they have very different address data sources. Maybe it's not so obvious here, but also the structure of those addresses are different. Because we now have descriptions of the different kinds of addresses used by these different organizations, we can integrate the address data into a single database. So what you see here, the namespace tells you which organization it is, the class tells you which kind of address it is, and then depending on the class of the address, we know the meaning of the components that follow. So the street address has an address number, a thoroughfare name, and a town name, whereas the Sapo type rural village address only has a house number, a village name, and then it also has a post office name. So to explain to you the usefulness of this also in today's world of online shopping, very often today when you have to enter your delivery address, regardless of where you live, which country or which region or what kind of address you use for yourself at your house, usually you get the same components that you have to fill in. So in South Africa, for example, the zip code or the postcode doesn't really help, but very often it is a compulsory field when we do online shopping. So now, if you think about a global repository of addressing classes from different countries, we could develop a website where, depending on the country, it knows which address classes are in use in that country, and then depending on the address class that you select, it would display different address components for you to fill in. So then we don't force people to fill in things that don't exist, and this also helps us with address verification. And this brings me to the second part of the addressing standards. It is currently under ballot as a draft international standards, and while the first part was very much about data and describing what an address is and how we can exchange this data, the second part takes us into the physical world. So it's about deciding what kind of address should be assigned to what kind of object in the physical world, and how do we maintain this. And this standard is particularly important for the developing world. As you can see from those photos, there are many areas of the world where people live without an address, and then they're kind of invisible. In fact, there is a United Nations report that estimates that about 4 billion people in the world, that's 50% of everybody, does not have an address. Or they are over-addressed, as you can see from that door there, where different organizations each assigned a different kind of address to a particular dwelling, which then creates a lot of confusion. This diagram provides a bit of an overview of what's inside the second part of the addressing standard. And at the core, you'll see there's a good practice and there's a governance framework. The good practice is about how we assign addresses and how we maintain them in the physical world. And then the governance framework is about how do you govern all of this? Because there are many stakeholders involved in addressing, obviously the people who live at those addresses, but also then there are organizations assigning those addresses. Sometimes with different components, there are different organizations like responsible, for example, for street names and house numbers and place names. And then there are also those who use the address, for example, to do utility planning or to use addresses in their navigation. So in this standard, we look at if you want to claim that you have a good practice for assigning and maintaining addresses, what are the requirements that you should meet, and also for a governance framework for how the addresses are managed and governed. What are the things that need to be in place so that you can conform to this international standard? In any standard, there are always requirements that you have to meet in order to claim conformance to that standard. For this second part of ISO 19160-2, we divided it into the good practice and the governance framework. So you can either claim conformance with the good practice or with a governance framework, or both. It's up to you. You can decide. It depends on what is relevant for you as an organization. And then we grouped these requirements further into, for the good practice, some general ones, and then some principles related to addressing and also related to data. And then for the governance framework, there are some general requirements, and then there are some related to the stakeholders involved in the governance framework, and some are related to the whole process of if we assign or update or change an address, what are the processes that need to be in place and in which order should they be executed. So if you want to show conformance to ISO 19160-2, it's the same as for any other standard. You have to decide to which part of the standard do you want to conform. For part 2, this means you have to decide, do you want to show conformance to the good practice and the governance framework, or only one of them? And then once you've made your decision, you then study each requirement for that good practice or for the governance framework and check whether your good practice or governance framework passes the conformance test. And if you pass the conformance test for all requirements, then it means you can claim conformance, that your good practice, for example, conforms to ISO 19160-2. And this is the same as it is for any other standard. So let's look at an example. I've just chosen requirement 3, which is about the conceptual model, because we looked at this earlier in the presentation. Requirement 3 states that a good practice shall specify the conceptual model for the classes or types of addresses assigned and maintained through the good practice. This includes a description of the address reference system. It is a set of address components and the rules for their combination into addresses. So this is something that one needs to check, whether the addresses assigned and maintained by an organization, this could be a city, it could be a country or a region, specifies in some way or the other the conceptual model that describes what these addresses look like. What you see here now is just the way in which in ISO TC 211 standards we specify how requirements are tested and how we show the results of testing a certain requirement. And the way in which this is done is described in ISO 19105. So at the top you see the test case identifier. This is just a unique identifier for this particular requirement. It's not so important when we look at good practices and governance frameworks, but when you want to automate testing, for example, of software, then these unique identifiers become very important. Then a test method is just a different way of stating the requirement that helps anyone who wants to check conformance to know how they should do that. So here we say check that the good practice specifies a conceptual model, and then we explain the rest of the requirement. And a good practice is typically described in one or more documents. So it could be a national standard together with specifications by a certain organization or a certain protocol of how different stakeholders interact. That may differ from one country or one organization or community to another. Then we have the reference for this, and then we have the test result and the test outcome. And I'm giving you an example from the draft international standard, which was provided by New Zealand. So in the case of New Zealand, there's a profile of ISO 19160-1, which is the conceptual model for all kinds of addresses in New Zealand. And then they also describe how they make sure that addresses that are assigned in New Zealand conform to this conceptual model. And in this case, then the test outcome is pass. So for this requirement, New Zealand meets conformance. There are other options. You could fail this requirement, or you could partial pass is another option. You can read up about that in ISO 19105. Yes. Here is another example from the draft international standard. So requirement 17 is now about the governance framework. and it states that this governance framework, whatever it is, shall exercise authority and control over address assignment and maintenance through policies with well-defined decision-making structures and procedures. In other words, if you want to check conformance, you'll have to make sure that there are policies and that there are well-defined decision-making structures and procedures. So here then are the results, again from the draft international standard for New Zealand for this requirement number 17. So in the case of New Zealand, there's no specific legislation about addresses, but there are several acts and each one of them then mention addresses, and collectively they meet the requirement 17 for a governance framework that specifies these policies, and that then there is, clear decision-making structures and everybody knows who's responsible for what and for what kind of decisions. So they've assigned themselves a pass. As you can see with this kind of standard, it's not like data interoperability or software that something is going to crash if it doesn't work. The aim with this standard is to help countries or organizations like cities and municipalities to reflect on how they assign and maintain addresses and then look for opportunities to improve this. So if they don't meet the requirement, they could state that they conform to ISO 19160-2 except for a certain requirement, and then they could go to decision makers and ask for the funding so that they can improve their good practice or governance framework so that they could meet all the requirements in future. So as you can see, the aim of this standard is not so much black or white, it's more like a guide. And then also think about developing countries, not necessarily something like a country like New Zealand where things are already very well managed. Think of countries in Africa where there's no addressing infrastructure. So they, for example, could look now at these conformance test reports provided by Australia, New Zealand, other countries, and then learn from that and implement addressing in their countries based on what they see in other places, and then start filling in those requirements one after the other. Everybody knows that this will be a long process. You won't necessarily meet all these requirements the first time, but eventually you can work towards that. So when we submitted this second part as a draft international standard, we were contacted by ISO and they asked us, do we really want to have all these conformance test reports by the different countries? There's about 10 of them in the draft international standard. Do you really want to include them in the standard? Because they make the standard very long, and then in some countries where you still pay per page for a standard, it makes the standard very expensive. The other drawback is that it's very difficult to update. You have to wait for the whole revision cycle of the standard. So it may make sense to separate these conformance test reports from the actual standard, because then countries, as they improve, they could just update this. And so we have submitted as South Africa a comment, and I think Sweden is going to do the same, to say that let's take the informative annexes showing the conformance test reports of different countries, let's take them out of the standard, and then Mats has started putting them on the TC211's website so that they become freely available and you can have a look at that. He's starting to work on that, but for the decision we'll have to wait for the DIS ballot to conclude. Thank you very much. I hope this has given you some insight into the addressing standards, and particularly the second part, and why it is useful to have conformance test reports, not only for oneself, but you could also share this information to help other countries. And if there are any questions, you are welcome to contact me. I hope that Mats is in the audience and a few other people who are involved in the standard, and they hopefully can answer your questions. Otherwise, you are welcome to contact me via email and I'll get back to you. And I hope to see all of you at one of the future TC211 plenary weeks. Thank you. And I always have to acknowledge the South African Bureau of Standards, who has supported me and funded me with my involvement in standards since 2006. Thank you.
Okay, so hopefully that has brought you all up to dress. Okay, is that better? Yeah. Okay, hopefully that's brought you all up to up to date with addresses. And as Serena said, if you want to contact her about anything, that's really good. The thing that struck me about that presentation, I must admit, was just spent a lot of time talking about conformance, so it's all very well as producing standards, but we do need to be able to prove conformance to them. We've come to the last section of 3 speakers, but before we do, there is time for a quick coffee and a comfort break. And if you want to come back into the room for 25 past, that would be great. So see you all shortly. Thank you.